Good morning, good afternoon, and good evening. Today I'm working on a 5-watt LED bulb that I want to reduce the current on so that it would be like a third of the power. Someone wants this done for their bedroom. And so the main chip, the main IC chip that we're dealing with here is not something that I'm familiar with, but I looked up the data sheet, and I'll put some of the information here somewhere. I looked up the data sheet of the main IC, and I believe that there is a current sense resistor that if I triple the value will reduce the output by a third. Let's quickly go under the microscope and let's take a look at that. So this is the main chip I'm talking about, and it's a BP9022A. And so pin number 1, which is right there where the dot is, pin number 1 is the current sense pin. And so that is connected to the 1R1 resistor there, right there, the 1R1. So I look, based on what I saw in the data sheet, and once again I'll put up the relevant information for this here somewhere on the screen. Based on what I saw, if I triple this 1R1 and make it to like 3R3, it will accomplish what I want. Now, before I start with this, I'm going to measure the current that is going through the bulb now as it is. So I'm going to put, I have a clamp meter. I'm going to put it on the black lead here, and we're going to measure the current that is being used right now. And then after I make the change, if the thing doesn't blow up, we're going to measure the current again, and hopefully it'll be about a third. As I was trying to attach the clamp meter, one of the leads here broke. These leads are a bit too short, so I'm going to desolder the other lead also and replace them with wires that are a bit longer. Okay, it's done. Let's measure the current. Let me zero out the display. There we go. And I'm going to plug it in. Let's see what it draws. Okay, so it's drawing 2.4 amps. All right. Now, because the resistor I want to remove and replace is just below this area here, this thing here is in the way. So I'm going to desolder the two wires that come from this to the board so I can work on it more comfortably. And I'm going to cut out this this heat shrink. I hope I have a replacement for it. I just wanted to clear the two holes for later when I want to put the wires back in. Alright, so I'm gonna remove that 1R1 resistor that you see there. I'm gonna use a bit of hot air. Hopefully it goes well. (400°C) and 40% airflow on an Atom ST862D. Okay, that went quite well. Let me do a tight of it. Clean up. Now, I've saved that resistor in case we need to reuse it. I found a 3R3 resistor, but I'm fairly certain it's the wrong size. Let me move this and I can show you. So this is a scrap board that I have. Here we go. I actually have two of them. They are a bigger size, but I think I can make it work. Anyway, only one way to know. I'm gonna remove, where are they? Okay, here. I'm gonna remove one of them and then we'll hope that it works. Oh, it's molten. Ah, it's the glue under it. You know what? Let me do this offline. It's not really relevant to this repair, and I'll be back. Alright, so I was able to finally remove the resistors. What worked for me was basically using a twisting motion as opposed to pulling it out. By twisting it helped with the glue, to overcome the glue. Okay, I've zeroed the probes out, and we're going to measure to make sure that these are close enough to 3.3. Let's see. This is actually 3.3 on the dot. And the other one also 3.3, pretty much on the dot. Okay, so either one will work. Yes, this is the same multimeter that I did with a rechargeable battery, and I still haven't recharged the battery. Still going on the same charge from when I first did the project. I'll put a link to that project up here somewhere if you're interested to watch it. I'm going to use again 400°C, but only 30% airflow. Add a bit of flux and see if I can jiggle it into place. There we go. I'm going to cool it down a bit with my pad. Alright, I think this is, yeah, it's cool enough. I'm going to give it a bit of a clean. Use a toothbrush. That's an idea. Okay, I think we're looking good. Quick, I'll give you a quick microscope view. There we go, 3R3. All right. First, I'm going to do, let me twist, okay. First, I'm going to do a test to make sure that nothing blows up. And then we'll do the current measurement again. All right, time to test. I haven't tested offline because if this blows up, then it'll be the end of the video, and I wanted to capture that in the video. So here we go, all is set. I just need to plug it in. I'm gonna stand a bit far away just in case. 3, 2, 1. Okay, the bulb came on. Nothing blew up, at least so far. Okay, so let me disconnect the power, and I'll see if the capacitor needs draining, and then we can do the current measurement. All right, so if I recall correctly, before we measured 2.4 amps being drawn. So let's see whether that has changed. Turn this on. Still on DC amps. Let me zero this out. Okay, and I'm going to plug it in now. So 1.7 amps. Okay, so it went down from 2.4 to 1.7. That's about half, right? A bit more than half. Okay, so perhaps that resistor, we need to put a bigger value. Instead of 3.3 ohms, maybe 5 ohms. But anyway, this is a result. Yeah, let me think about the 5 ohm resistor. Okay, so I've decided to keep the 3.3 ohm resistor, and I'll explain why when we do the final test. In the meantime, I desoldered these two wires and put the heat shrink around the circuit board and the components like it was before. So I'm going to assemble it, and then we'll come back for a final test, and I'll explain about the resistor. Let's do a final test. I've reassembled this, and I'm going to plug it in right now, as you can see. Now, the reason I decided not to replace the 3.3 ohm resistor that I put in is that I noticed the side effect of what I've done. When I unplug the bulb, there's flickering now, which wasn't there before. So I don't know what that's about. I'm going to have to research that. And if I find the reason why that is so, I will add it in a pinned comment on this video. And maybe also in the description. But let me show you what I mean by the flickering. I'm going to hold it like this, okay? And I'm going to unplug it now. So you saw how that was flickering for a while before it finally turned off. Anyway, I hope you enjoyed this video, and see you on the next one. Bye-bye.